Today I'm going to discuss about the prism and prismatic property of lenses too. But let me make you clear that I'm not going to talk about prism as a relation to orthoptics, and I'm not going to talk about prismatic effect and image jumping and hand and neutralization method. And there are a lot of things that we can talk about the prism, but these topics fall under ophthalmic dispensing or under definitely under orthoptics. But today we are going to just talk about prism as a optics point of view, only as an optics point of view. Okay, so let's move. So prism is a portion of transparent isotropic substance including between two polished non-parallel surface that called refracting surface. So this is the two polished surface, non-parallel surface, and here is the angle which is called apical angle, which is apex angle. And the angle of incidence and angle of deviation determination is always very simple because we can find normal to the surface. It's very easy. So in case of prism, it's always and always light rays always deviates towards the base, and images always deviates towards apex. It's always, there is only one scenario in which these things exactly gone reverse. So let me tell you that scenario. If this is prism of 1.5 refractive index, and if we uh, put this prism in the surrounding where refractive index is greater than 1.50, so greater than the material made by prism is made of. So in this case light always travel towards the apex and images always fall towards the base. So it's central important to understand. In only one condition we can make it, that light ray deviates towards the apex, which is exactly opposite to normally happen when light ray deviates towards the base. Normally light rays always deviates towards the base, which means image shifted towards the apex. So and prisms, there is no vergence. Okay, in prisms vergence is zero because there is no change in vergence in case of prism. Prism only shift the image, isn't it? It's very important to understand. Prism has zero vergence, but we calculate the power of a prism is a prism diopter, isn't it? Prism diopter, not in a diopter, but in a prism diopter. It's central. I will going to discuss about this. So the thin prism deviation, in case of thin case, not in case of thick prism, but in case of thin prism, deviation angle is uh, refractive index minus 1 into apical angle A. It's very simple and useful formula. The utility of this simple relationship lies in the fact that the deviation of angle in a thin prism is not dependent upon the angle of incidence as long as deviation angle is small. So it's let me explain in next topic what is the core difference between thick and thin prism. But this formula is for the thin prism. So I'll discuss the difference between thick and thin prism. So we generally thought that greater less than 10-degree apical angle is called thin prism, and greater than 10-degree apical angle we called is thick prism. Okay, this is the generalized differentiation. But what is the main difference between thin prism and thick prism? In case of thin prism, angle of incidence doesn't matter. In case of thick prism, angle of incidence matters. Okay, let me tell you in another way. In case of thin prism, the angle of incidence here and here and here doesn't matter. Approximately same angle of deviation we can found, isn't it? From this graph, if angle of incidence is here something like 10-degree or 20-degree or 30-degree, so angle of deviation is same. But in case of thick lens, this three portion has very different angle of deviation. So in case of thick prism, angle of deviation is dependent on the angle of incidence. But in case of thin prism, angle of incidence plays very little role. That's why it called thin prism and thick prism, and we differentiate. It's very important slide to understand the difference between thin prism and thick prism. It always comes in your examination as an optometry student. So this is some pictures for thin prism and thick prism. Okay, there are some pictures: loose prism and bar prism. So prismatic property of lens. So lenses, which is basically lenses has what power diopter, which can change versions. So lenses has prismatic property, which is prismatic effect. Lens itself is not a prism, but it has prismatic effect. So not generally we consider plus lens is made of by base stacking upon base, so it makes something like that. To minus lens we consider apex stacking upon apex, we make something like we have this kind of idea. So it's a generalized idea. It's very useful when we are solving problem in ophthalmic dispensing, and definitely we are solving problem in real clinical scenario. It's central important to think like this. So so central segment has no prismatic effect power. Yes, definitely. When you come to the optical center, another definition of optical center, that point of a lens which has zero prismatic effect. So you can tell that prismatic effect is there is prismatic effect zero, then it could be optical center is definition of optical center. Another point, another way we can make the definition is that adjacent segment has a prismatic power, but prismatic power depend upon the two things: how distance from optical center, how long the distance. One is distance, another is power itself, power of the lens. If higher the power, higher the prismatic effect, higher the distance from optical center, higher the prismatic effect. It's a very simple way to understand. So so further from the lens center, larger the angle at which each other, and the more prism power it creates. So as you move from the optical center, away, the more of prismatic effect you get from the lens. Remember, it's not about prism, it's about prismatic effect. It's central important to understand. So prismatic effect by the lenses uh, can be given by the rule which is called Printice rule, and Printice rule is very simple. C is the distance from optical center, F is the power of a lens, and both are directly proportional. As you move away from the center, far and far away, the more prismatic effect it creates. The power of a lens goes from 0 to higher, no matter what, plus or minus, higher and higher, more the prismatic effect going to happen. So two things matters, and one important point you have to understand: the distance from the optical center towards that point, whatever point in the lens, should be taken at centimeter. It's central important. A lot of students make that mistake. They calculate with the help of millimeter. It's not that, or not in a meter too. You have to calculate with the help of a unit of centimeter. It's central important. That distance should be in the centimeter, not in meter or millimeters. It's very important point to understand. So basic point, there is also the sign convention, and we always know that the sign convention is like object distance, image distance, the angle is always in a anti-clockwise direction. It's simple stuff that we have already discussed. So in this what do you call a small numerical. So see, 6 diopter is a power, and 3 mm is a uh, what do you call the distance from optical center. 3 mm we convert it into centimeter, it's central important, into 6, which means 1.8 diopter. And base in is central important to discuss prismatic effect within base in, base out, base down, and base up. These are the four things we have to understand. It's very important in case of orthotics and in case of dispensing point of view. So I'll make another video, I think in future, so how to deal with this base in, base out stuffs and all these things, maybe in dispensing series or maybe in orthotic series, but it will take time. So now currently I'm in optics series. So again in this numerical, 7 diopter is a power, 3 mm nasally, and 2 mm inferiorly. So we have to convert in a centimeter and centimeter. So 0.3 centimeter, 7, 2.1, and again 0.2 centimeter, and again 1.4. Base out and base down. It's another video topic of the video. So nasally we call it basin if base towards nasally. If base is out, base out. If base is towards temporarily, base out, and all these things for plus lens and for minus lens. It is for another video, but it's completely okay for now. I want to discuss this point, this particular slide, and with the help of my pen. Basically I want to introduce this concept. So let me have a clear picture here. I don't know where it lies. Wait. Okay, wait. So let me draw one thing. So this is the a clear blank. So let me tell you, let me make a clear distinction. This is optical center. Okay, so I will make only two lines, only two lines, only two lines, only two lines, only two lines. See, so let's take example. This is a 5 diopter power, no matter what, plus or minus, it doesn't matter. So just simply put it like this. So 5 diopter, let's take example 5 diopter in plus. Okay, so if it is plus, then it's made by base and base. So if it's 1 centimeter away, it's 5 prism. 2 centimeter away, it's 10 prism. 1 centimeter away, 5 prism. If 10 centimeter away, 2 and 5 and 10, 5 and 10, isn't it? 1 centimeter and 2 centimeters. So it's for making it easy. So let's take an example. If I put one prism in this lens, one prism, extra prism in this lens, what happens? That's what the example of this slide. See, this is the prism where two prism base up in every possible way, and when I combine this with this, which is actually four prism lenses. Okay, four prism lenses. This is 1 centimeter and 0.5 centimeter. When you place this in this, the combination is quite fantastic. See, this is base up and 3 centimeter up, and add to base down, it reduces from 6 base down to 4 base down, because base up is opposite, and 2 base down, you add 4 base down to 2 base up, it makes, see, 2 base down. Now previously here's the optical center, which is 0. Now it shifts towards one step ahead, isn't it? It's 2 base down and 2 base up, combination becomes 0. And previously where optical center lies, at that point it comes 2 base up, because here everywhere is base up, isn't it? Same power, because it's prism, there is no optical center, and we add power, and so it increases. So in this fashion, there is shift of optical center when you put extra plane prism, extra, sorry, not plane but extra prism to the lens, core lens. So sometimes it comes in multiple choice questions, and in real scenario when you are literally going to do the dispensing of prismosphere lens, isn't it? Prismosphere lens, prismosphere, I think the term is this, prismosphere lens. At that point you have to understand how optics plays, and this is a great picture from, I think, from Keating. So you please go in the Keating book and just try to understand what I wanted to explain, and find this picture and understand this concept. It will help you in your life, really help you in your life. So you must understand this concept, how you add one prism in normal sphere, normal spherical power, and make prism sphere, and how optical center shifts because of the prism. It's a really important concept that you have to understand for the future. Okay, for now this is the very best book for the beginner, golden book, and my favorite book of all time, Professor Dr. George S. Emilis. So I hope it will work. Bye bye.